Good afternoon, students. So today we see length of perpendicular from pole to the tangent. So in the last classes we have solved problems on angle of intersection of two curves, and also the orthogonality of two curves. So today we see what is a length of a perpendicular from the pole to the tangent, and what is what are pedal equation. Okay, how do you write pedal equation in terms of P and R? Okay, and how do you write a pedal equation in Cartesian form? Okay, so all these we are going to see in this class. So let us start with length of perpendicular from pole to the tangent. So here let r is equal to f of theta be a curve. So this is r is equal to f of theta be a curve, and let p be a point on this curve, and from this point draw a tangent. Okay, so draw a tangent. So then let ON be the foot of the perpendicular. Let ON be the foot of the perpendicular from the pole onto the tangent. Then let the angle between the radius vector and the tangent be phi, and let theta be the angle between the radius vector and the initial line x. Okay, so with all this, now we see what is length of a perpendicular. So let this line ON is known as the perpendicular from the pole onto the tangent. So here this is the tangent, right? This is the tangent, and on this tangent we have drawn a perpendicular line, or we have drawn a line which is perpendicular to this tangent. Okay, and this line is called as ON. That means it has some length. So let P be the length of this ON. So this P is called as the length of this perpendicular. Because this line is perpendicular to this tangent, therefore this is known as a perpendicular. So P is known as length of this perpendicular. Now to find the length of the perpendicular, so let ON is equal to P. Now observe that triangle OPN is a right angled triangle. Now from this triangle we write sin phi as ON by OP. So sin phi means that is opposite by hypotenuse. So opposite is ON, hypotenuse is OP. So ON by OP. So ON is P and OP is the radius vector R. So which is equal to P by R. Now cross multiply this, we will get P is equal to R sin phi. So this is the formula for the length of the perpendicular from pole to the tangent. Okay, so in the examination they may ask derive the equation for length of a perpendicular from pole to the tangent for 2 marks, or otherwise they may ask only write the formula for length of the perpendicular from pole to the tangent. Now remember that this formula is very, very important while finding the pedal equation of a given curve. So remember this formula, P is equal to R sin phi. And one more formula we have that we see now. So here we prove that with usual notation, prove that 1 by P square is equal to 1 by R square plus 1 by R raised to 4 dr by d theta whole square. Okay, so this is first one. Second one, prove that 1 by P square is equal to U square plus du by d theta whole square, where U is equal to 1 by R, where P denotes the length of the perpendicular from pole to the tangent at any point R theta on the curve R is equal to f of theta. So now proof. By using the length of the perpendicular formula, so it is given by P is equal to R sin phi. Okay, so now reverse this. So P, when we reverse this, it gives 1 by P is equal to, this is 1 by R sin phi. Okay, so here P is equal to R sin phi. So what he has done, squaring on both the sides, which get P square is equal to R square sin square phi, squaring on both the sides. Next, reverse this. So 1 by P square, this is also to be reversed. So 1 by R square sin square phi. Then 1 by P square is equal to 1 by R square. Now 1 by sin square phi is cosec square phi, or which is equal to 1 by R square. Cosec square phi can be written as 1 plus cot square phi, because 1 plus cot square theta is cosec square theta. So using that, this cosec square phi is 1 plus cot square phi, or 1 by P square is equal to 1 by R square into 1 plus, now this cot square phi can be written as 1 by tan square phi. Okay, so now we know that angle between the radius vector and the tangent is given by tan phi is equal to R into d theta by dr. Okay, or 1 by tan phi, reversing this, 1 by tan phi is 1 by R into dr by d theta. Now replacing this 1 by tan phi here. Okay, so then it gives 1 by P square is equal to 1 by R square into 1 plus 1 by tan square phi from this equation. So already we found 1 by tan phi is equal to 1 by R dr by d theta. Now squaring on both the sides, we will get 1 by tan square phi is equal to 1 by R square into dr by d theta whole square. So replace this here. So 1 plus 1 by R square dr by d theta whole square. So this one. So replacing that, we get 1 by P square is equal to 1 by R square into 1 plus 1 by R square dr by d theta whole square, or 1 by P square is equal to 1 by R square plus 1 by R square dr by d theta whole square. Okay, so this 1 by R square into 1 by R square gives 1 by R raised to 4. So this is the required derivation. Now to prove the second one, that is this one. Here we write, let U is equal to 1 by R. Then differentiating with respect to theta, du by d theta gives, this is du by d theta, then differentiation of 1 by R is minus 1 by R square into differentiation of R with respect to theta, dr by d theta. Now this equation 4 becomes 1 by P square is equal to 1 by R square plus 1 by R raised to 4 dr by d theta. Now this is, just now we have derived this. Okay, so this becomes 1 by P square is equal to 1 by R whole square. This 1 by R square can be written as 1 by R whole square plus this 1 by R raised to 4 dr by d theta whole square can be written as 1 by R square dr by d theta whole square, which is equal to 1 by R means U. Already we have assumed that U is equal to here, U is equal to 1 by R. So 1 by R means U, that gives U square, plus this is du by d theta. So here we have found du by d theta. So this is du by d theta. So du by d theta whole square, or 1 by P square is equal to this U square plus du by d theta whole square. So this is the required derivation. Now we derive the equations of pedal equation. So here how to find the pedal equation? Let the curve be R is equal to f of theta, and then we write the equation 1 by P square is equal to 1 by R square plus 1 by R raised to 4 dr by d theta whole square. Now call this equation 1 and call this equation 2. Now from this equation 1 and 2, we eliminate phi and theta. From this equation 1 and from this equation 2, we eliminate theta. Then we get a relation between P and R, which is called as a pedal equation. Okay, so first take the given equation R is equal to f of theta given curve. Then write the pedal equation in this form: 1 by P square is equal to 1 by R square plus 1 by R raised to 4 dr by d theta whole square. Call this equation 1 and call this equation 2. Now find phi in terms of theta using tan phi is equal to R into d theta by dr. Now using this equation, differentiate this with respect to theta, and then using this formula, we find phi in terms of theta. Next, finally eliminating theta between 1 and 2. Using this 1 and 2, we should eliminate theta, then the resulting equation becomes in terms of P and R, which is called as Gödel equation. Okay, so now with this I conclude this class and continue in the next class. Thank you.